Numerical Series 7, 1 kg of air initially at a temperature of 127 degrees Celsius expands reversibly at a constant pressure until the volume is doubled. If the gas constant of air is 287 joule per kg Kelvin, the magnitude of work transfer is dash kilojoule. Round off to 2 decimal places. So before we solve the given numerical, let's understand the question according to the given data. So let's write down the data given in the question. So the first data, it is mentioned that 1 kg of air. So here we consider mass that to be m is equal to 1 kg. It is mentioned that initially the air is at a temperature of 127 degrees Celsius. So here we consider the initial state as 1. So initial state of air having temperature is considered to be T1, that is equal to 127 degrees Celsius. So here in this question it is mentioned that the air expands reversibly at a constant pressure. So let's understand this with a coordinate diagram. Let's say PV diagram. So here we consider pressure along y-axis and volume along x-axis. So here we consider this as the initial state of air and it is denoted with 1. The air expands reversibly at constant pressure and the process continues until the volume is doubled. So after the completion of constant pressure process, the state 1 becomes state 2 and this process will continue till the volume of air gets doubled. So initially the volume is V1 and after completion of the constant pressure process, the volume becomes V2 and according to the question, the final volume, or you can say V2, is equal to 2V1 and V1 is nothing but it is the initial volume and V2 is the final volume for a constant pressure process. So this is for constant pressure process. Next data is given the gas constant of air, that is 287 joule per kg Kelvin. So that is considered to be R. Gas constant is considered to be R, that is equal to 287 joule per kg Kelvin. Now the question arises that what we are going to calculate here. We are going to calculate the magnitude of work transfer. So here we are going to calculate the work transfer for the given process. So the process is constant pressure process. So constant pressure process is nothing but it is otherwise known as isobaric process. So here we have to consider the work done for isobaric process. So we know that the work done for isobaric process is equal to PdV, that is equal to P V2 minus V1. So here we know that as the process is constant pressure process, it means P1 is equal to P2. So in place of P, let's consider it to be P1. So it will be same. Nothing changed in the magnitude of pressure. And V2 is 2V1 minus V1. So here we consider P1 and 2V1 minus V1 is V1. Now see, given mass is air and air is an ideal gas. So here we consider, as air is an ideal gas, we consider PV equal to mRT. So this relation we are going to use here. So in place of P1 V1, we can substitute it as mRT1. See, mass is given, R is given, and initial temperature is also given in the question. So if you put all the magnitude here, we get the isobaric work done. So here we consider M as 1 kg into R. R is given 287 joule per kg Kelvin. Let's convert this into kilojoule per kg Kelvin, that is equal to 0.287 kilojoule per kg Kelvin. So R equal to 0.287 kilojoule per kg Kelvin into temperature is given in degrees Celsius, that is 127 degrees Celsius. So if you convert this into Kelvin, it becomes 127 plus 273 is equal to 400 Kelvin. So now substitute T1 as 400 here. So if you solve this one, you get the magnitude of isobaric work done as 114.8 kilojoule. But see, in this question it is mentioned that round off the answer to 2 decimal places. So let's mention the 2 decimal places, that is 114.80 kilojoule. So this is the final answer for the given question. Thank you. See you in the next video.